There's my standard frontal section, right? Looks a little bit different. What got cut off here, this is an ear. There's actually an ear here. Cut off an ear. And then here's the ear on the other side. Okay. Here's going to be my thalamus. Okay. The only thing that might look a little different here is I've accentuated the temporal lobe. So I'll go ahead and label that. So label the two of them. This is my thalamus. And this is my temporal lobe. Okay, they talked about the organ that's responsible for receiving sound information from the external environment. That's going to be your cochlea. So I'm going to represent the cochlea by this little snail shell-shaped organ here inside the left and right ears. Okay, so that's your cochlea. One thing we talked about previously when we talked about the cranial nerves, there's the cochlear nucleus. It's just above the position of the vestibular nucleus in the pons here. And the cochlear nucleus is going to be the cranial nerve nucleus that receives information about hearing. Is you have out of the cochlea, like the video just showed, coming out of the hair cells, you have axons coming out of the hair cells that travel as the auditory portion of the 8th cranial nerve and synapse with the cochlea. So on the right side you synapse with your right cochlear nucleus, and on the left side you synapse with your left cochlear nucleus. So this is the auditory portion of cranial nerve 8 bilaterally. And this is the right side, and then this is the left side. To make it easier to see, I always like to put my midline in. This way I'm going to draw both sides. After the cochlear nucleus, which is located in the caudal pons, the next structure up that you need to be aware of that's part of the auditory system. In the cerebellar system, if you remember, we talked about the inferior olivary nucleus. In the auditory system, it's called a superior olivary nucleus, and it's about in the middle of the pons. So this is going to be your superior olivary nucleus. Okay. Next player up, there's going to be at the region of the inferior colliculus. Okay, so your inferior colliculus is going to be here in the caudal midbrain. There's going to be a nucleus in the inferior colliculus. Okay. So once the auditory portion of the 8th cranial nerve coming bilaterally out of the cochlea reaches the cochlear nucleus ipsilaterally. Yes, Johnny?
Is the inferior colliculus that nucleus?
Yes.
Oh, it is a nucleus.
Yeah, that's
okay.
that's what it's called. So information traveling is the auditory portion of the 8th cranial nerve coming from the cochlea, comes down and synapses with the cochlear nucleus ipsilaterally. Then the cochlear nucleus sends out axons that travel ipsilaterally to the superior olivary nucleus, as well as contralaterally to the opposite superior olivary nucleus. Okay, and the same thing happens on the left side. Axons from the left cochlear nucleus synapse ipsilaterally with the superior olivary nucleus and contralaterally with the superior olivary nucleus. And what we've seen before is every time something decussates or crosses over, we give it a name, and the name of this decussation is known as the trapezoid, Trapezoid body. And the trapezoid body is nothing more than the decussations of axons coming out of the cochlear nucleus on their way to synapse contralaterally with superior olivary nucleus. In other words, when sound comes in from one side, as long as it makes it to this cochlear nucleus, it's processed bilaterally, almost immediately. So we see that? All right. So in the superior olivary nucleus sends out axons that travel ipsilaterally to the inferior colliculus. Okay. And then at the level of the inferior colliculus, this information is again crossed back to the opposite side. So sound is traveling back and forth through both sides. As long as that cochlear nucleus and that auditory portion of cranial nerve number 8 is intact, it's going to make its way up the brainstem, and then coming out of the inferior colliculus, you have axons here that are going to synapse with a special nucleus in the thalamus. Okay, does anybody remember the name of the nucleus? It's part of the thalamus that's involved in the visual system, visual tracts? That would be the lateral geniculate nucleus. Well, in this case, what you're looking at is, for auditory system, it's the medial geniculate nucleus. So inferior colliculus sends out axons that synapse with the medial geniculate nucleus of the thalamus. And again, to make the comparison for the visual system, you had axons coming out of the lateral geniculate nucleus of the thalamus going to the superior and inferior portions of the occipital lobe. Does anybody remember what those are called?
Macular fibers.
So they're
Radiation.
Yes, yes. That's going to be your optic radiation. Well, same thing. This is your auditory radiation. Only these auditory radiations are going to come out and synapse here with your temporal lobe. Okay, so the medial geniculate nucleus sends out axons that travel in something known as your auditory radiation. And they synapse here in the temporal lobe. So this is your auditory radiation. So optic radiation for vision, auditory radiation for hearing. Whoa, I spelled that wrong. Radiation. Okay. And that's it. That's all you need to know. Questions? Vestibular stuff, a lot of vocabulary, a whole lot of vocabulary. The auditory stuff isn't so much. Yes, Chris?
Sorry for missing it, but
Yeah.
the inferior colliculus, does that manifestation like immediately, or
It-
just crossing over for ipsilateral and contralateral?
So the the information travels up to the level of the inferior colliculus, and at the level of the inferior colliculus, then it crosses over to the opposite side, contralaterally. So there's just a decusation there just among the inferior colliculus. So information coming up, by the time it reaches that point, it's crossed over twice. That's excessive decusation. We'll talk more about that. Any other questions? That's it. Good job. Thank you. Get me it done.